So, hello everyone, good morning, good afternoon, and good evening, depending upon the location you are joining in. Hope you all are doing well. My name is Vikram Pol, and I am the representative and EV battery expert at batteryline.com. And I will be the moderator of this webinar or this session today. Since this is our first ever webinar organized by batteryline.com, we take this opportunity to introduce ourselves. So I will go ahead and share my screen now. Hope you all can see my screen. So who are we? So we are community of EV battery manufacturing experts where all our experts and partners have provided their solutions or shared their expertise by providing their equipment right from mixing to the formation and packaging, line integration solutions, automation solutions, and many more. As the name battery line, we focus on the line which helps in manufacturing of battery cells, modules, and packs. And we do not focus on the battery in itself. We are continuously looking ways to improve production, reuse, and recycle of batteries. We believe that the sharing information amongst the experts will increase the real power to battery solutions. Our mission is to achieve more together, and we believe in the power of networking, and through partnership we want to make a greener, sustainable, and faster impact in the field of battery manufacturing. We as a community believe that we cannot drive clean cars on dirty batteries, and by dirty batteries we mean that batteries which are manufactured by old manufacturing techniques or old school methods of manufacturing. Our vision is to be the expert platform regarding battery line solutions of the future. In this slide, you can see our current partners, and as of today, we have 26 equipment suppliers in our community. So these are world-leading equipment suppliers such as Kamau, Fanuc, MPAC, and many more, as you can see here. And these equipment suppliers have provided their solutions and proven their expertise to Giga factories in Europe and USA and even across the globe. And as well as we have four battery makers into our community, which are IM3NY, Anadox, Ionitech, and Stodot. We have a small video to present to you regarding batteryline.com. So I will just go ahead and play that video right now.
The future is electric, and it's moving fast. We see more and more electric vehicles around us, and all those awesome machines use batteries. Big beasts of batteries. This means we need a lot more and bigger factories, everywhere, for every known type of battery, and those yet to be discovered. All these batteries need to be produced in different ways. We need to automate. We need to innovate. We need a revolution. From manufacturing to recycling, in cooperation, the battery process experts will make this happen. We will analyze user data, increase efficient use of source materials, discover use for end-of-life batteries before they get recycled. The possibilities are endless, but time isn't. We need you. Join the battery pack now and start working on a brighter future. The future is electric. Batteryline.com. Join the battery pack.
Yeah. So thank you very much for your patience and listening to the introduction of batteryline.com. And without taking much of the time, let's jump into the main topic of today's webinar. In the meantime, the audience can share your questions in the chat box, which we will take up in the Q&A session in the last. Battery cell cases are very critical part first, and the first thing which we see when we look at the battery cell is the battery case, and it also contributes to about 8 to 9% of the battery cell material cell raw material costs. Today's webinar is going to be very much interesting if you would like to know about how battery cell cases are manufactured in masses in gigafactories. Uh, Today's topic is experts talk on turnkey solutions for battery case manufacturing for gigafactories. We are very glad to have our experts, Mr. Markus Rover, who is the Director Global E-Mobility at Schuler Group, and Mr. Joachim Christensen, who is Sales Manager EV Batteries at Jorgensen Engineering. Mr. Markus and Joachim, thanks for joining us today.
Thank you.
Yeah. So, Mr. Markus, can you please go ahead and please introduce yourself and Schuler in short?
Your mic is off, Markus.
Thank you, Joachim. The old fault. Yeah, my name is Markus Rover. I'm in charge of production equipment to manufacture battery cell cases and traction motor cores at Schuler Group. When we talk about Schuler, we talk about a company which is now 184 years old. It was founded in Göppingen, small town near Stuttgart, still the headquarters today. Our focus is completely on metal forming and everything you need for application of metal forming. That means presses, tools and die. Usually we take care of the whole production process. Our top customers are in the automotive industry. Approximately 60 to 70% of our sales is in this industry. Now also for electric vehicles. We have other segments like forging, household appliances, and also minting industry. We currently employ 5,000 people in more than 40 countries. And our focus is to take metal forming into the next level, where we have a fully digitalized or what we call smart press shop. And I'm happy to be here today. Thank you.
Thank you, Markus, for that introduction. Mr. Joachim, please can you introduce yourself and a bit about Jorgensen Engineering?
Yeah, for sure. Thanks, Vikram. First of all, my name is Joachim Christensen. Been working with Jorgensen Engineering for 7.5 years. I've been both a project manager and a mechanical design manager. And since 1.5 years ago, I entered the sales within our new, offering, the EV segment, coming from the food and beverage and infant formula industries, pharmaceutical industries, entering this new exciting segment, about 2 years ago. I would say we are a company of around 160 employees, located all in Denmark. We have a small office in the US as well, but I would say our main office is where almost all our employees are located. We are part of the Exano Group, which is a large assembly of different companies within these niche segments that we are in. We were founded in 1933, so quite an old company as well. Not as old as Schuler, but still old. So 90 years of experience. We have a wide range of customers in many countries, and have done a lot of turnkey lines, turnkey installations, and been an integrator in many different fields all over the globe, basically. But our experience is for sure coming from the food segment, from the infant formula segment, and now entering this exciting new segment of EV batteries.
Okay.
Thank you for being here.
Okay. Thank you, Markus and you for that introduction. And we would like to know from both of you how Schuler and Jorgensen Engineering, through partnership and collaboration today, is providing solutions for cell case manufacturing. in the Giga factories? And Markus, you can go ahead by answering this question.
Yeah, okay, man. If somebody is looking to manufacture a cell case, he has to do several things. Main focus is on converting the raw material into the cell case. That means the forming application. And this requires several machines to do this. So the next task is then to bring this material, the preforms, and also the final product from A to B. From, let's say, from coil material up to the fully packed and inspected and washed can into a tray. And there, we as Schuler take over the part of forming. This is our focus since all this time, and also integrating all these machines into a line control. But we were looking then for a partner to do this handling of the material, of the preforms, of the cans from A to B to C to the finished tray. And there we found our cooperation partner today, Jorgensen. And I think, Joachim, you can continue what you're offering as a solution here.
Yeah, for sure. And this is, of course, utilizing the core competences of Schuler within the forming industry with all those years of experience really getting into this. And the forming of the battery cell cases is, of course, their main expertise. In order to support this in the best possible way, we have a lot of experience of line integrations and connecting machinery in the most efficient way, not to or to increase throughput of those key machines. That is, I would say, the finest task for the integrator and the line builder around the presses in this case, is to support the key machines, which is Schuler's presses, so they produce at their absolute maximum, and we have the possibility to convey, support, communicate, and support the coming processes with the flow of cans and raw material, making sure that the line is running at its very optimum. This is our key task to solve this. Another big thing is, of course, the track and trace and the ability to handle products in all aspects, and being able to manage the line flow, and also the making sure that the quality product which is produced is coming out in the right way, and also if any bad things happens, that we exclude that from the finalized product. So this is, I would say, the cooperation here is very much between the key machines and making sure that the throughput is the best as possible and most optimal.
Yeah. Okay. So it was very interesting to know how Schuler and Jorgensen are cooperating today. Coming to the next question, recalls due to manufacturing defects of cells are causing difficult for the end user to gain trust in using EVs. So what's the role of automation and Industry 4.0 solutions in manufacturing of cell cans? Yeah, that's our next question.
Yeah, I think this is a very hot topic in the automotive industry. And as Joachim also mentioned, track and trace is something which is required in the automotive industry already for many applications. We have applied this first for automotive panel parts, so that we are linking the production data, the process data, all this information to the part. So the part itself gets smart with a timestamp. Every and all information regarding the production process is stored in a cloud system and can be recalled then at any time. Yeah, and in principle, I think this is also the way forward for cell cases. also because of the mass production here, additional steps has to be solved. But I think this will be the future, that every part has a certain marking, will be detected, and the production data will be stored with it. I think the technology is there. The first applications are there in the automotive press shops by Schuler, and this will come also for cell cases.
And for sure, it's very important, and I agree with Markus here that this is a huge focus also to avoid any foreign contaminations on the finalized battery or product that we're producing here. To go more in detail, we are working with basically being able to utilize tests for the tools to make sure that what is being run on the system is not released before it has been validated by personnel to quality control. So this is very important that we are able to control the batches of product actually coming out. So product will not basically enter the ongoing cycles and the coming processes if they are not controlled and quality controlled in the right way. So we are able to control that. Another thing is also that we are utilizing machine vision and vision tasks to basically check and validate each and every product in some aspects, depending on the application. But this is the 100% control is something that we are looking into, and also a demand from the end customers are going in that direction. So that is what we see. Vision control on each and every product is where we are going, and also to stamp and make sure that we have a unique ID on each and every material flow from coming towards the battery. So for sure, this is a huge focus, and for sure, a lot of automotive OEMs has also realized this and are putting up the demands. You have also seen some recalls history, so it's very important to be able to control your production and being able to track and trace from can cell level to the different materials going into the battery.
Okay. Yes. Yeah. We feel that the information about the Industry 4.0, which you both have given, is very informative and will be very helpful for our audience as well. So coming to Mr. Markus, we have seen that most of the cell makers today are preferring to purchase the cell cases from a third party or a contract manufacturer. Why it's important to set up a cell case manufacturing line instead of sourcing it from outside or somewhere elsewhere?
Yeah, I would say it's not a question of sourcing on, and it is more the point which you said, that the cell case manufacturing should be near the cell assembly. Who is running the cell assembly, the cell case manufacturing? I think this is a different topic, and there are a lot of scenarios possible. But when we produce the case next to the cell assembly, we have a lot of benefits. There are no transport costs, not the, let's say, unavailability of transport as we experienced in the last years, delays. This is not the case. There is a cost reduction because you don't have this, let's say, packing and then destacking at the cell assembly line in this regard with let's say with export packing material. You don't have the packing material, and you can really have a quick feedback between the cell assembly and the cell can. So this could be a through the wall application. Really, that would be then really the almost the closest place to be. Yeah, as the cases going through the wall into the cell assembly, or it could be maybe fab to fab, also fabrication in fabrication in the next production hall, or maybe facility close to the cell assembly. I think this is what we will see in the future because of these benefits, and this is not the question who is then doing what, but how it is done. That is important.
Yeah, thank you very much, Marcus, for that explanation. That we came to know from this that the cell case manufacturing line must be near to the cell assembly process. So, Mr. Joachim, coming to you, Jorgensen has been experienced in handling around food and infant formula and pharmacy industry for about 90 years, and now it has entered into the EV battery market. What similarities and differences you see in between these segments, and where is the challenge you are seeing here?
I would say that that most of what we see is actually quite transferable from the segments that we have been within the food and the infant formula industries, pharmaceutical industries. The product containers that we have handled is actually some of the same sizes and shapes as a battery. So the handling of the actual product is not a problem for us. One thing which is really new to this industry and is something that we see a lot in the food industry is the line speed. Line speeds here above 2,000 a minute is not an obstacle, because of course it is a challenge, but it's not impossible to do. So this is something that we have quite a lot of experience with, and something that we can transfer directly to the EV battery market. This also means that we can support a high throughput depending on which application it is, and we're able to support different types and shapes of batteries. In any case, I would say the challenge is actually to transfer the applications to a new market with new demands. So this means that the circumstances that you're building your machines and your solutions under are not the same. There are some additional demands coming into this. What do you say? A combination of normal production requirements, but also automotive OEM requirements is what we see, and that is a challenge, of course, for a company like us to look into this. And there, of course, we need to work with this in order to support this at the standards we are now facing. This is something that we are working a lot with, and also to our customers towards, and also together with Schuler, trying to adapt this to the current industry, as the standards are being set as we are basically speaking now. So for sure, the challenge is to adapt the known solutions that we are coming from into this new and rapidly changing segment. Another challenge is, of course, also the need for the speed in this segment. You need to provide solutions very fast, and you need to adapt a type of manufacturing equipment which has been usually used in Asia for many years to the European and American market, which is also a challenge to take that knowledge and do that input to Western Europe and to the US.
Okay. Yeah, thank you very much, Joachim, for spotting out the differences and the challenges faced in the industry. Coming back to you, Marcus, what is the difference between prismatic can and cylindrical can production process, and which one is more challenging and why?
Okay. Yeah, I think this, when you look at the parts, it is obvious that the prismatic can is more challenging for the forming. Yeah, it is not this symmetry as symmetric as with the round can. Prismatic can with the sharp edges is requires let's say more forming stations and also different methods to produce. But in principle, the processes itself are very much the same. It depends on the material. Yeah, we see, for instance, for steel material is the main raw material for cylindrical cans. There are also some stainless steel applications for prismatic cans. For steel, you have the process of deep draw, which you combine with wall ironing to produce these cans. And in the case of aluminium, which is the majority for prismatic cans, and it's also some applications for round cans, there you have a choice between two processes, the deep draw, and the other process is impact extrusion. Both combined then with wall ironing process. There is certain advantages and disadvantages for both processes. We see for big prismatic cans, there is a huge advantage for impact extrusion is the material utilization and also the speed of the forming machine. Deep draw, I think, is better scalable. If you have certain ramp up scenarios. So this there you have options which you can choose from, and the difference here is that you use different raw materials. In case of deep draw, you start with a coil material where you cut out blanks and then draw these cans into cylinders, so to say, into cups and redrawn cups, and then finally you come to the can. Whereas with impact extrusion, you start with a piece of aluminium, a so-called slug, and impact extrusion machine forming this slug immediately in a container in what we call preform, which is relatively net, shape is relatively close to the final shape, but then by wall ironing gets to the final shape. So these processes are well known for many years. It's nothing new, and the combination of this forming gives you for both cylindrical and prismatic is applicable. It gives you also similar results. By meaning of geometry, accuracy. There are maybe slight differences in the transition areas of the can, then depending on the process, but these are really then the details. And then they have a difference in speed. When we talk about cylindrical cans, we see today lines with line speeds, like I mentioned, of up to 2,000 per minute. With the prismatic can, which is more difficult to form and also requires different machinery, bigger machinery, you have maybe factor 10 less. Maybe even more. So we have their speeds maybe 100, or if you put in parallel legs of machines, then you have maybe 200, 300 per minute. But okay, these cans are also bigger, so have contain more energy. So you need also less cans in an electric vehicle. So this fits somehow the need of or demand for such cases and the production speeds.
Okay. Thank you, Markus, for listing out the difference between the cylindrical case and prismatic case manufacturing processes. Coming back to you, Joachim, cleaning and conveying of cell cans and after being manufactured is a big challenge for the industry. What is the solution for it?
Well, we can start by the challenge, because batteries are quite fragile in the way that they're composed. So small foreign particles can disturb the quality of the battery itself. Therefore, it is extremely important that the cell is kept clean while you produce, and also going into cell assembly, that the products and the material flow going into there is clean. That's why cell assembly is a clean room. and there are high standards and high you say demands to the production environment. This is typically ISO 6 or ISO 7 clean standards, so that defines the amount of particles that is allowed in the air. It also defines that you are not allowed to have a certain type or certain types of foreign particles on the product itself. So that is to be avoided. And here we are not talking big portions or big things that you can see by the naked eye. You're talking microns of contamination here. And as we talked about before, we are having line speeds of up to 2,000 a minute. If you're going to the cell assembly, that is not the line speed of a cell assembly line. That would be 5 times less, or even more, even less than that. But even so, you still need to clean the material going in and make sure that you have no contaminations to this. There we utilize clean compressed air sometimes, but also just cleaned air, deionized typically, and then we validate that we are blowing off any foreign particles. That would be metal particles, plastic particles, whatever you can get from a production environment before you are doing the cell assembly itself. That means that you have no foreign particles, or you try to avoid the foreign particles in the battery itself when it's being assembled. If you do not do so, and that you do not have control of this, the foreign particle, you will have an unstable battery, and initially or eternally that will cause either the battery capacity to be lower, or serious fault in the battery module when you reach that. So quality is key here, and also the traceability, so you can define if something goes wrong, then which batteries was then wrong. Of course, you will be able to some point to quality check your batteries, but it's really important that you clean them and make sure that you prevent these contamination coming in. And this is a huge topic and a huge, challenge for the industry, and is approached in many different ways on both battery manufacturers and OEMs. But it's for sure a very important subject, and something we take very seriously, and we have, I would say, some state-of-the-art solutions for this, making sure that the material flow going into the cell assembly is correct, especially on the cans, for sure.
Yes, Joachim, thanks for this deep explanation about how it's important for cleaning the cans before it goes for the cell assembly. So, Mr. Marcus, do you see any other formats like the outer case design coming up other than cylindrical or prismatic? And also for coming to the pouch cell, because we also see that pouch cells need a protection. Are there cans manufactured today to protect the pouch cells in the electric vehicle application?
Yeah, also I would not say a can, but for sure the pouch cell as a soft package requires the structure in the electric vehicle. That means some parts which give some guiding, some also structural strength. So usually the pouch are put into this structure made of sheet metal and put into a battery module, and the module are then assembled into packs. The prismatic and the cylindrical cells have some structural strength in itself by their material. And what you can see there in the last years, that the modules are skipped when using these cans, and there are applications where the cells are directly assembled into the packs, taking advantage of this structural strength. Also the pouch will always require some additional parts to gives this ability of structure. Do we see other formats? I would say not completely new formats, not completely new type of housings. What we can see is different formats, and also sometimes what is seen now on the market, very long prismatic cells, which are then not made of a can, so to say, so with a closed bottom and a open top, but with two open sides. So it's more like a tube, and they are then closed with two lids, the open sides. So these are then formats which were in the last 2 to 3 years coming to the market. Seemingly then these cells are then also have some advantages in the assembly process because they are larger, so they require not so much handling. And it will be interesting to see which format is then, let's say, the future. I personally think there will be still all of them available and needed on the market, looking at the demand of the market. So it's not one format fits all.
Mr. Marcus, we cannot hear you right now.
Oh, he fell out, I think.
Yeah, until he comes, Joachim, I have a question for you. The industry is facing a lot of challenge in line integration solutions, where in the cell manufacturing line, Jorgensen can provide its high-speed handling and conveying solutions.
Well, basically, we have until now been focusing, of course, very much around the presses and the very start of the line, which has basically concluded into looking into the material flow around cell assembly, where we see a lot of opportunities in general. Because there is a lot of material flow going into the cell assembly itself. You have the lid, you have the can, you have the jelly rolls that you need to put in. So a lot of different things is going in: separator sheet, anode and cathode, notched rolls. So you have a lot of material flow in the cell assembly area in general. So to support and keep these machines running, we see a lot of opportunities. Also because we have a lot of, I would say, solutions which supports this in general, that we have the solution to convey different types of material, no matter how they look or how they are handled. So we're providing handling systems for basically all types of containers coming from the food and infant formula pharmaceutical segments. We're used to face different types of material which has to be handled, moved, treated in every sense. So we see a lot of potential there. The other big part is, of course, that we understand the throughput needs to be high. So basically, when you have high throughput going into the cell assembly, not the battery count itself, but all the materials going in, is usually might be higher throughput, and that is something that we're very good at supporting and see a lot of opportunities in this, especially in the high growth and the knowledge that we are coming from the other segments. Another area which we see a potential is, of course, in the packaging area, where we have a lot of experience, end of line equipment in general. So that could be packing, I would say, the cans before shipping to the battery manufacturer. So that could be the end of line of a press line, where we're also working closely together with Schuler on this and support support this transition for the Schuler machines. But it can also be finalized batteries at the battery manufacturer, which is to go to market, either to module production or to automotive OEMs. It can also be battery production integrated for the automotive OEMs. I would say there is a huge space and touch point, because integrating automation skills and material flow is something that you have almost everywhere in the production line of a battery. And our knowledge around the clean environment, clean production, the demands for track and trace, traceability, cleanability, clean design, CE marking, safety, and in general controls. That is really the key, I would say. So we have a lot of different potentials here at Jorgensen, but also at Schuler for sure, that to go into different areas of the battery production. But for sure, cell case is very important, and something that we have a lot of experience with, together with Schuler, and we can foresee that this is a
I
market
think, Marcus,
which will
we had
for sure
lost
grow
you
a lot.
during the last time, and now, yeah, if you can continue by saying your message around the cell formats.
Yeah, I'm very sorry.
No, it's
So I
fine.
hope the connection is better now. Yeah, I'm not sure how much you or how far I was into the matter, but I said that the new formats are coming up, with longer cells, which are formed also as a more like a tube than like a can, with two open ends and two lids to close, and this gives very long cells, which seemingly offer certain advantages in the assembly process. So what I then see next is the still on the horizon, the solid state battery, where for sure also the pouch cell will still have its stake in this. So I think all formats will continue to be on the market and required and produced.
Okay. Yeah, I think that was the last question. The last question was for Mr. Joachim, and we have completed our question. And now it's the time for Q&A session from the audience. So we have one question from Christian Gramlich. So how many parts per hour can be handled with this battery line, and which processes step is the bottleneck? I think it's a question for you, Marcus,
Yeah.
and Joachim also.
It was already mentioned that cylindrical cells, we see line speeds up to 2000 cans per minute, and there is no, let's say, really bottleneck, because most of the machines can be parallelized, so that you put next to each other, so you can grow over time. So the forming itself is not a bottleneck. I would say it's then really the question how many cans are required. I think there is not this bottleneck where you say, okay, this is the forming speed where it is not working anymore. As we have not come to this point yet.
Yeah, and to add to this is that the machines that we see, we sometimes, if there is a capability of a press, for instance, running at 500 cans per minute or whatever, and having that out, we will scale it by adding additional machinery, and you will combine it in the conveyance system. So there is an opportunity, and I would say that compared to other areas in the battery production as such, for sure, we do not have a lot of bottlenecks in the can making line. So this is lines which is for sure built for high capacity coming from other segments as well. So for sure there is a lot of capabilities which likely the battery manufacturing industry could learn from also on this behalf. Markus, this is about lubricants.
Yeah. Yes, lubricants are required for forming. So this is also the reason that the can stamping is not located in the cell assembly area in this clean room, because it's somehow a wet business. That means all the forming requires oils or emulsions, and this, I would say, it is not very different or very special lubricants. It's lubricants which for deep draw or also for impact extrusion. There are certain, I think, adaptations for the material, but nothing really that's special. So you need the lubricant or the emulsion to cool the active tooling. You need it to improve the lifetime of the active tooling. What is important, that you look, as I mentioned, there are certain forming steps, for instance, impact extrusion, wall ironing, and then you have also to wash off this lubricant. So you have to look for a system that all these lubricants and the detergent and the washing process is working together, but because at the end you need a clean can, and you need high lifetime of your active tooling. It is at the end a question: does this whole process work together? So this requires also some tests for sure with the lubricants, and but so far we see here very good solutions on the market. But there's still room for improvement. Die lifetime is always something which could be improved. Every customer would like to run the dies forever, but so that is for sure also some work to be done in the future.
Yeah, I think I had lost you for a minute because of the bad internet connection. But I see a new question from Natasha. Which material would be taken in the future? If aluminum, could you say which alloy would be the favorite?
Yeah, also for prismatic cans, we see alloys like the 3000 series. For instance, for deep draw 3003, there, which is a alloy which is also extrudable, but also other 3000 series which could be used. And we have also seen, let's say, pure aluminium, as 1050, for instance, also in industrial use. For sure, the alloys have the advantage of higher strength. So when we talk about using the cell also as a structural element in the battery pack, it makes sense to go for alloy. Yeah. Also maybe for lightweighting, so to reduce the wall thicknesses. So I think the future will be more on the alloy side than on pure aluminum.
Okay. I hope this answers your question, Natasha. A question to you, Mr. Joachim, is that is Jorgensen having an experience in handling all type of battery formats?
Basically, for the prismatic and for the cylindrical, the answer is yes. Also in different formats for both the empty can, but also moving to the finalized batteries. Then we are doing that in different areas of the battery production. So it can be in different stages. Yes, we have handled both cylindrical and prismatic battery cells. We have also handled finished modules. which is a bit different from this, but finalized modules, which is basically what you put into the electrical vehicle itself. So a lot of different stages of the battery production is something that we are working with and getting experienced in. I would say for pouch, this is not something that we have experienced with from the battery segment as such, but pouches in the food industry, pouches in the pharmaceutical industry, so handling that is something that we have done for many years, and as previously talked about, this handling philosophy is quite transferable. This means that we can utilize some of our experience with handling pouches to the battery industry. But for now, handling batteries, then we're only talking about cylindrical and prismatic.
Okay. Yeah. Thank you, Mr. Joachim. And I think we have come to an end of this webinar because we don't have any more questions from the audience. Thank you, Mr. Markus and Joachim, for taking out time and participating in our webinar and sharing your expertise. And thanks for your support for batteryland.com through sharing knowledge and expertise, which ultimately contributes to the greener and sustainable impact on battery manufacturing.
Thank you for the invitation.
Yeah, thanks a lot. It's really interesting.
Yeah, thank you. So we would like to thank our audience too for attending our first ever webinar. Stay tuned and follow us on our LinkedIn page and to get information about our current and future members and their expertise, and also information about our next webinar regarding battery manufacturing lines. We would also like to improve ourselves for the next time. So please provide your valuable feedback in the evaluation form after this webinar ends. So thank you, take care, and see you next time.